It is my pleasure to greet you again. This is the concluding lecture for the entire course. In this concluding lecture, I want to overview what all we have done week by week, and that way you will have an overall picture of the course. In week 1, we did review of basic fluid mechanics, including governing equation, non-dimensionalization, classification of equation, PDEs, type of boundary condition, and then we derived what is steam function equation. In week 2, we spent time on grid, then we started going to the Taylor series of expansion. From Taylor series of expansion, we got different finite difference formula, first order, second order, forward, backward, central, higher order, uniform mesh and non-uniform mesh. And in week 3, we explained different properties, conservativeness, boundedness, transportiveness, then numerical errors, then characteristics associated with the finite difference scheme in terms of consistency, conservativeness, stability and Lax equivalence theorem. We explain all this with the help of example problem. We also gave different assignments based on this. Then we also explain finite difference equations for different model equations and explain for those example different properties. Week 4 was a main subject. We started talking about finite volume formulation in detail. So, we talked in detail about convective terms, nonlinearity associated with the convective term, how to treat convective term exclusively. We had different approximation procedure. We explained all of them with the help of the corresponding formula in detail. Then we also took an example problem and variation in the example problem and explained the performance of these schemes and illustration explaining how the same scheme behaves differently for different numerical condition. And week 5 was a time integration procedure, where we talked about different time integration methods available and comparison of them, explicit formulation, implicit formulation, and how to construct any higher order methods for time discretization as well. Then we move on to what is known as a pressure velocity coupling method. We learned the pressure does not have a separate equation, but somehow it needs to be linked between momentum equation and mass equation. We had explained 3-4 procedure, simple, Mach and then projection method. In week 6, we talked in detail about turbulent flows, characteristics of turbulent flows, modeling of these equations and different models available, advantages and some application. We also gave different assignments based on whatever we explained in this module. And week 7 is dedicated for matrix inversion procedure. Whatever method you follow for discretization, finite difference, finite volume or finite element method, finally they will end up in the form of a matrix equation. So, we have to know how to invert them, and there are different methods available, direct method and iterative methods. And in direct method we listed 3 examples: Gauss elimination method, LU decomposition and Thomas algorithm for tridiagonal matrix algorithm. Similarly, in the iterative method we explained many methods, Gauss-Seidel method, then SOR methods. We also talked about what is known as a preconditioner, ill condition of a matrix and preconditioner, different preconditioning procedures available. And putting together all of them, we had in 8 week a working code problem considered was flow in a lid driven cavity, and then we explain the numerical algorithm step by step using the projection step method. Then corresponding code, working code was displayed, and line by line of that code was explained. Then at the end of it, we had a complete code, then actual running of the code, and the results obtained, everything was explained in detail. We believe this has created interest in you. We also believe this has created some confidence in you. We wish that you continue your interest and learn more and more. Thank you.